All right, now we know the value for b. B is 4, but we don't just stop there. Why? Because we need the values of b and a. So now that I know that b is 4, I could now say, back to my first equation, if b is 4, then a plus 4 is supposed to give me 8. Oh, that's what I was trying to check. Okay. So if I know b is 4, I can say a plus 4 is supposed to give me 8, looking at this first equation. And therefore, a is equal to 4. Everybody good with that?
Yes, miss.
Okay. So my answer, the values of a and b, is 4, b is 4. Okay. Can I clear this?
Yeah. Wait, so the answer is A equal 4 and B equal 4, right?
Yeah, let me just write out how the answer would look like. So this is the answer. So after doing all this, it's good to write, final statement kind of thing. A is 4, and you might put like a comma, b is equal to 4. Everybody good, right?
Yeah.
Okay. Hold on, right? Hold on. Okay, right. So you got your values. A is equal to 4, b is equal to 4. So yeah, that's the answer, right? We know that's the answer. We worked it out. So, but just in case you're in your exam and you want to make sure that your answers are correct, you can go back to the original function. So the original function was this, right? F of x is equal to x cubed minus. This is not part of your working, right? You finish it. You know your answer is a is equal to 4, b is equal to 4. This is just for you to make sure that your answers are correct. Just double checking your work to make sure that your values are right. So this was the function that they gave us, and they told us when this was divided by x plus 1, the remainder was equal to 6. So we said that f of minus 1 is supposed to give me 6. If I say, so my values of a and b, I got that a is equal to 4 and b is equal to 4 as well. So what does that mean? That means that my function, if the values of a and b root 4, and the function is really this. If you want to double check your answer, we know that f of minus 1 is supposed to give me 6. So if I substitute minus 1 into this equation, I'm supposed to get 6. If I don't get that, well, your value is wrong, or at least one of them is wrong. I need to check it over, right? This is just to make sure that your answer is correct. So f of minus 1, we know that it's supposed to be 6. So let's see. Let's double check this. So minus 1 cubed, that's minus 1. Minus 1 squared is 1. Minus 1. Minus 4 times minus 4 over, anyways, 4. Get the idea. Plus 4 is equal to minus 1 minus 1, that's minus 2. Minus 2 plus 4, that's 2. And 2 plus 4 is 6. It adds up. And that's how I would know, okay, my answers, a is equal to 4, b is equal to 4. It's correct. Everybody good?
Yeah.
Oh gosh, that sounds so tough. That's just me double checking my answer. That's not a part of what you have to write down for your marks, right? That's just to help you. The examiner does not want to see this. That's just to help you to make sure that your answers are correct. Everybody good?
Wait, the A and 4, they give you that number equal 4 or you just
Oh, that's why I said this is to double check your answers to make sure.
oh
Yeah, you got your answer to be A is equal to 4, B is equal to 4. But to double check to make sure that these answers are correct, you could substitute the values into the function and double check to make sure that f of -1 is 6.
yeah.
Okay. I hope I didn't confuse anybody. Yeah, that was just to help you. If it did not help you, forget what I just said. You can do that. But it would be beneficial to you to understand if you understand what I did here. So can I clear this?
Yes, yes.
Okay. Right? Okay, that was the last one. So everybody good with factor theorem? Yes, no,
Uh, mm, wait,
no.
let me see
Yes,
one
what is the
example. Let me
question?
see one example. I don't remember what's that though.
Factor theorem is what we're just doing.
Oh, that? Oh, yeah, yeah, all right. It's all right.
Mm.
Because I just don't know the topic name. It's I just,
Oh
I
gosh,
don't really focus on topic.
you need to know what topic you're doing. Okay. Factorizing polynomials. Hey. Okay. Let me show you something. Let me ask you a question. We know that when we're using the remainder theorem or the factor theorem, the first step is to put the divisor equal to 0 and solve for the value of x. But does anybody know why we do that? Or you just, going with the flow? Somebody tell you to do that, so you just do it. That's a question, by the way. Does anybody know why we put the divisor equal to 0 to solve for x? I will take that as a no. Am I supposed to assume that's no? Okay, I think that's a no. Okay, let me just go through this first and then I'll tell you why we put the divisor equal to 0 to solve for that value. Okay, first step. When factorizing polynomials, using the factors of constant term and the polynomial, find a factor of the polynomial. Okay, now I need to explain this. So for quadratics, oh gosh, I think yes. For quadratics, when we had to solve, when we had to factorize quadratics, oh gosh, they were given the quadratic y is equal to x squared plus 2x minus 3. When we had to factorize quadratics, remember how to factorize quadratics? Yes or no?
Yeah, I know.
When we had to factorize quadratics, we know the rules, right? We said we break up this b term into two terms, where the two terms that I get when I multiply them, the result is supposed to give me AC, and when I add them, I'm supposed to get the value of B. So if I wanted to factorize this quadratic, it would be x squared plus 3x minus x minus 3. And then I would continue to get my factors. I would say this is x plus 3 equal this, x plus 3, and then I would say, okay, my factors are x plus 3 and x minus 1. That's how we factorize quadratics. Everybody remembers that?
Yes, miss.
Yeah, I remember. Wait, what was the topic name a while ago? Factorize, factor, something.
Factor theorem.
Oh, okay.
So that's how we factorize quadratics. A quadratic is actually a polynomial, right? A polynomial to the second degree. But we have a set way to factorize quadratics. We know these rules. But if you have a quadratic to the, give me a quadratic, a polynomial to the third degree. So one like x cubed minus x squared plus 2x plus 7. How do we factorize that using this method? You can't, right? Because unlike quadratics that have, well, this quadratic that has 1, 2, 3 terms, this has 1, 2, 3, 4 terms. So I can't apply this method. I need another method to factorize this third degree polynomial. But the question is, what method do we use to factorize this polynomial? Everybody follow it so far?
Yeah, I follow it.
That's one person. What about the others?
Miss, can you repeat?
Repeat one.
Miss, the question you were asking.
I actually following so far.
Yes, miss.
Okay. So we established we can't use this method to solve polynomials of the third degree and higher. But how exactly do we do that? Well, recall from quadratics. Factorizing means to find the factors of this quadratic. I would say these are my factors of the quadratic. Everybody remembers that? I need to go slow.
Yes, miss.
Oh gosh, that's one person. What were the others? Okay. And if I solve by factorization, we know I would put this equal to 0. I'll put each factor. Oh gosh, somebody's trying to try. I would put each factor equal to 0. So x plus 3 is equal to 0, x minus 1 is equal to 0, right? And then I'll solve for the values of x. X is equal to minus 3, and x is equal to 1. But what did those values tell me? Those values told me the roots of this quadratic. So if I got my value,
Why you do that, miss? The yellow part, miss. But that's the answer. I already missed the green part. You have to do that?
no, this is factorizing. This is solving by factorization.
Oh, I remember. I just put that. Oh,
Yeah, this is just
I remember. I put that alone.
this is just factorizing, and this is solving.
Mhm.
But you need to remember, when we were doing quadratics, when they asked you to solve, it was to find the roots. Most times it was to find the roots of the quadratic, right? That was the whole purpose of solving, right? So I would say if my values of x are minus 3 and 1, then the roots of this quadratic is minus 3, 0, and 1, 0. Everybody remembers this?
Yes, miss.
Yeah. I got it.
Okay. And like, if I had to draw this on a Cartesian plane, I have my y-axis, I have my x-axis, x, y. This would look like a smiley face. But that's not necessarily how it would look, right? That's just, okay. I would say this right here, this is 1 root, and that's minus 3, 0. And then I'll have this one here, and that's 1, 0. Everybody remembers that?
Yeah.
Because the root of a
So
quadratic is
negative 3. Wait, so the left would have, wait, so
this.
left is 1 and 0. Oh, wait. Let do.
What you don't understand.
Wait, alright, yes, miss. I understand.
Okay. So that's how you solve the roots of quadratics, right? Polynomials. Can I erase this?
Yes, miss.
Okay, I just erase this. So by factorizing and then solving my factorization, I was able to tell you the roots of this quadratic. The factor theorem. So say they gave me a factor, right? Like, okay, let me write it up. Say they actually told me that my polynomial to the third degree is this. Minus 2x squared plus x plus 3, right? So this is the polynomial they gave me, and they told me that this right here, x plus 2, I'm not saying that this is real, right? This is just me making up an example. I don't know if x plus 2 is really a factor of this. Let's just assume. X plus 2, they told you that x plus 2 is a factor of this polynomial expression here, right? Cool. If it's a factor of this polynomial expression, factor. So you see, just like the quadratic, when we had the factors equal to, gosh, what was it? It was, what was it? It was x plus 3x minus. Just like I had the factors of this quadratic was this. A factor of this polynomial expression is this, right? Everybody following that so far?
Yes, miss.
Okay. And we also know that to find the roots of a quadratic function by solving by factorization, I put this equal to 0, put each one of them equal to 0, and I could get the roots, right? Same thing here. If I put this factor, just like here, I would put the factor equal to 0 to find the roots. If I put this factor equal to 0, because I know for a fact that it's a factor, I would say that x is equal to minus 2. And if x is equal to minus 2, then my root, according to what we know from quadratics, is actually minus 2, 0. Everybody following so far?
Yes, miss.
Okay. Cartesian plane. X. One. So say we know this root, right? We know this root is minus 2, 0. let's assume that this graph looks like this. So this is what the graph of polynomial to the third degree would look like. You're not required to learn how to draw this. It's just me explaining something, right? So it looks like this. Okay. Quadratic, which is the second degree. It looks like this, parabola. Why? It's a parabolic graph. This, it looks like you have two parabolas, right? A minimum, and then it looks like you have a maximum. That's what the graph to the third degree looks like. Like I said, not required to know this. That's just me showing you something. We found out that one of these roots is minus 2, 0. So what solving polynomials helps me to figure out is the other roots of this polynomial. Everybody good so far? Just like solving quadratic functions, it helps me to find the roots. Solving polynomial expressions, well, polynomial functions, also helps me to find the roots. Everybody good so far? Please tell me if I lost you.
No, miss.
Oh gosh, that's one person. What are the others?
Miss, I think I'm getting there, Miss. But
Anybody else? You lost or you following?
I'm good, miss.
Okay. Wait, who didn't answer me? Oh gosh, I didn't even see who didn't answer me. Okay. I hope everybody answered me. I don't even know. Anyways, right, so factorizing polynomials helps me to find the roots, just like solving a quadratic by putting the factors equal to 0, I'm able to find the roots, right? Using a factor, that's the whole you'll see it just now. When factorizing polynomials, using a factor, if I know a factor, so I know that a factor, assuming, right? I don't know if this is really true. We're just assuming that x plus 2 is a factor of this polynomial function. If I know for a fact that this is a factor, using this, I could actually find the other factors of this polynomial expression. If I find the other factors, then I would be able to find the other roots. How would I find the roots? Just like quadratics, you put factors equal to 0, and that's how you would find the roots. That's how you solve the roots, right? Then you need to remember this as we go through other. I wanted to tell you something. What was it? Hold on. It'll come back to me. What did I say? Gosh, I don't know. Oh, hold on. So you see that remainder and factor there and thing? Remember the first step was to put the divisor equal to 0. To solve for your value of x. When we got a remainder that was not 0, we said, okay, that is not a factor. So say we had f. So the same thing, right? On the divisor was x plus 1, so f of x minus 1. I mean f of minus 1. We got the remainder to be 6. By getting a remainder that is not equal to 0, we would say that this, well, gosh, trying to explain this in simple ways. I don't use any good. This is my polynomial expression. They wanted me to divide it by x plus 1. Say, when I divide by x plus 1, my remainder, so f of minus 1 gave me 6. So we know from what we just did, x plus 1 would not be a factor. It would not be a factor. Why? Because the remainder is not equal to 0. The remainder is 6. This came by me knowing that the remainder, when this is divided by x plus 1 is 6, I would say this is not a factor. So you see, when I factorize the polynomial, just like when I factorize the quadratic expression, I got x plus 3 and x minus 1. So I knew, okay, these two are my factors. Because my remainder was not 0, I know for a fact that x plus 1 is not a factor of this. So you see, the quadratic we had just now was x squared plus 2x minus 3. We know for a fact, because we can use the method that we always using, that the factors are x plus 3 and x minus 1. I know for a fact that x plus 3 and x plus 1 because we know a method to solve quadratics, we were able to find out that x plus 3 and x minus 1 are factors of that quadratic. We know that for a fact. So I cannot come and say x plus 3 and x plus 1 are factors. Why? Because I know x plus 1 is not a factor, it's x minus 1. But it's not as easy to solve. It's easy to do it with quadratics, but it's not as easy to do it with polynomials with degrees 3 and higher, right? That's why we're doing this whole method that you would see just now. I really hope you're following, right? So what does this tell me? Because I got a remainder that's not 0, I know for a fact that x plus 1 is not a factor of this polynomial expression. But you might be wondering, why isn't it a factor? Well, remember, linear form is in the form y is equal to mx plus c, right? Y is equal to m. What am I? Gosh, I don't know what to do. I'm just trying to find a way to explain this to you without using too many complicated terms. So I said because I have a remainder of 6, I know for a fact that x plus 1 is not a factor of this polynomial expression. What does that mean? It's not a factor. See, when I substitute the value of, when I substitute minus 1 into this, I'm not going to get 0. I'm going to get 6. Because it's not a factor, that means that it's not a root. So you see how I got minus 2, 0 to be a root of this polynomial. So the graph, this is actually a root, right? So it lies on the x-axis. See this, x plus 1, that is not a root. So what does that mean? I'm probably going to find it like somewhere up there or something. That's all I'm trying to tell you, right? Because I have a remainder, hey, this is not a factor of this, and therefore this would not be a root. It would be somewhere else on the graph. Because this has a remainder of 0. So it is a factor. It is a root. And it would actually lie on the x-axis. Did I lose anybody?
Wait, so the yellow dot equal 6, right?
This?
No,
Is that
this
it?
wait,
Wait.
this
About
on that graph. What is the yellow line represent as?
whatever this
Oh.
point is.
And the
So,
green
right,
and the
continue.
green line equal
These green dots,
green dot.
those are the other factors. That's the whole point of, no, those are the other roots. That's the whole point of factorizing the polynomial in the first place. Just like quadratics, you would factorize the quadratic and then solve to find the roots. Here, you would factorize the polynomial and then you would be able to find the roots.
All right.
Did I lose anybody?
No worries. No worries.
Factorizing polynomials. The whole point of me factorizing this polynomial, just like quadratics, well, one, is either to help me find the factors or it's to help me find the roots, right? So if they ask you to factorize the polynomial, we said it would be different from factorizing quadratics. Unlike quadratics, where we have these rules that we can follow, polynomials, it's different, right? We can't apply those rules to factorizing polynomials, and that's why it's a different method of factorizing it. A different method is to factorize polynomials. So the first step is to use the factors of the constant term in the polynomial to find a factor of the polynomial. When factorizing polynomials, it's helpful to know at least one factor, and then using that one factor, you'll be able to find the others. Let me show you how. So that's the first one. And we're given this example, right? They want you to factorize p of x, which is given by 4x cubed plus 8x squared plus x minus 3. You'll understand this step just now, right? So this step, looking at this example, they just told you to factorize this. First thing, remember, using factors of the constant term in the polynomial, we can find a factor of the polynomial. We can find one factor of the polynomial. So let me just show you real quick. If you have a polynomial to a degree, so your highest power is 3, so say you have x cubed minus 2x squared and so on, you're going to have 3 factors. So just like quadratics, the highest degree was 2, the highest power was 2, you have x squared and then continue. A quadratic had 2 factors. However, polynomials to the third degree, because this is to the third degree, I'm going to have 3 factors. So I'll have x. So let me just say it's x plus 1, x plus 2, x plus 3. Because this is to the third degree, I'm going to have 3 factors. Quadratics are to the second degree, and that's why you only have 2. So just remember that, right? This first step is to help you find one factor. And then using that one factor, you'll be able to find these other 2. So how exactly do we do that? Well, factors of the constant term. Boom. Gosh, let me show you the constant term. This is the constant term they're referring to, right? Minus 3 in this case. Factors. Well, it's factors of minus 3, right? So I'll just change that. Factors of minus 3 or factors of 3. It's 1 and 3, right? But you need to account for plus or minus. Positive 1, negative 1, positive 3, minus 3. So you can't just put 1 and 3, right? Because remember, a factor is any number that divides another number and the remainder is 0. Or you might say no remainder. If I divide minus 3 by 1, I would get minus 3, so no remainder. But also, if I divide minus 3 by minus 1, I would get 3, no remainder. So what does that mean? Yes, 1 is a factor of minus 3, but minus 1 is also a factor of minus 3. It's a factor, why? Because it divides minus 3 without leaving a remainder. So we have the function p of x is equal to 4x cubed plus 8x squared plus x minus 3. Using the factors of the constant term, which in this case was minus 3, so I'll change that. We need to find a factor of the polynomial. So I'll start off with 1. It's a trial and error thing, right? So I'll say p of 1 first. I substitute those values and I get 10. What does that mean? If I have a remainder that's not 0, then that is not a factor. So then I move on to minus 1. If I substitute minus 1 into this, I do get 0. What does that mean? This is a factor. So when x is equal to minus 1, if x is equal to minus 1, then my divisor is x plus 1. Everybody understands that?
Yes, me.
That's 1%. What about the others?
Yeah, I understand.
Okay. So then using this one factor, I can now find the other factors. But how do we do that? Well, we use long division. If I have, this is my polynomial, right? P of x, and I have one factor. Using this one factor, I can divide the polynomial by it to get the others. So if I said 4x cubed plus 8x cubed plus x minus 3, and I use long division to divide it, of course I would get my remainder is equal to 0. Why? Because I know that this is a factor, right? So how exactly do you determine the other factors of the polynomial? Well, you see this quotient that you get? When this quotient, if it's a third degree polynomial, quotient would always be a quadratic, right? And that's most likely what you would have to do. It would most likely for your exam always be a third degree polynomial. So when you divide the third degree polynomial by a linear divisor, you're going to get a quadratic as your quotient. Therefore, let me just show you something real quick. So I was showing this example before earlier in class. So if I said 128 divided by 2, we know that 2 is a factor of 128, right? Because it divides 128 without a remainder. 2 divided by 128 is 64. So what I would say is that 2 is a factor of 128. Yeah, we know that because it divides 128 without a remainder. But also 64 is a factor of 128. Because if I say 128 divided by 64, I'm going to get 2. Since if I divide 128 by 64, since I don't get a remainder, or my remainder is 0, I can say 64 is a factor of 128. 128 divided by 64 is 2. So this is a factor of 128, and this is also a factor of 128. Same thing applies here. If this is a factor of this, then this is also a factor. Therefore, I say my factors are this and the quotient,